Hey guys, BuildZoid here, and today we're going to be taking a look at a BIOS setting on Gigabyte LGA 1700 motherboards that allows you to limit the vid requests from the CPU. So the whole point of this is if you have like a 13th gen or 14th gen i9, i7, well, one of the Raptor-like chips that is affected by the degradation, and you want to be like extra safe or on the side of caution, this is literally one setting that you can use to get the CPU to stop sending insanely high voltage requests to the motherboard. I'm honestly kind of surprised that Intel didn't use this setting from the beginning. I don't know if they're going to use it in that microcode update that's supposed to come out in August. Um, but yeah, it's actually pretty cool that you can just tell the CPU, like, hey, if you want to, like, if you don't send stupid voltage requests to the motherboard. You can just tell the CPU not to do that, and it's amazing. So we're gonna take a look at that. Anyway, so the first things first, the setup here is I'm using a Rigol HDO 1104. I have a piece of coax soldered to a multi-layer ceramic capacitor on the back of the motherboard, and there's a 50 ohm termination at the oscilloscope. So that's what the oscilloscope is measuring. So it measures in high current draw loads, it measures a little bit high because we're measuring the voltage before the resistance of the CPU socket. In low loads, it measures a little bit low because the 50 ohm termination at the oscilloscope is like dragging the voltage down. So yeah, there's some resistance to a coax. I tried to compensate that out because the oscilloscope does have that functionality, but it's not perfect. So it reads a little bit low in low current loads, and it reads high in high current loads, because in high current loads, there's a bunch of voltage drop across the CPU socket, and we're measuring the voltage before the CPU socket. So, yeah, I also have a 20 megahertz bandwidth limit, which ultimately, like, sometimes I don't use that, but for this demonstration, it doesn't really matter if we're on the full 100 megahertz bandwidth or on just 20. So yeah, that is the setup here. Or like the measurement setup. Now for the motherboard, we're on BIOS F7E, right? F7E. The CPU I'm using is my 14900K. My 14900K kind of massively sucks. It has a VID of 1.498 volts for 6 gigahertz. So yeah, this chip requests some crazy voltages for like single core boost. So anyway, now what's significant about this BIOS is this is one of the BIOSes with the Intel default profiles. So yeah, and that's currently just set to extreme. Yeah, so with this, so this is like the latest Intel official configuration for LGA 1700, right? Like it's not yet like there's going to be another patch in August that is supposed to prevent insanely high vid requests. And apparently they're still testing that. I'm not sure what, like, one thing they could do is just actually use the setting that I'm going to show you here today. But I'm guessing, like, the thing is, the setting that I'm going to show you here today, it has downsides. Mainly that it eats into your performance. If your CPU really sucks, it eats into a lot of performance because your CPU naturally requests insane voltages. And when you tell it to stop doing that, it also stops boosting as much. But anyway, first a demonstration of some crazy high voltages. And I've actually investigated these a bit more closely, because initially I thought they were just like transient load release spikes. But no, it seems to actually be some kind of bug I'm not even sure if I would necessarily consider it a bug. Because it really looks like basically Intel's CPUs, when they send vid requests to the voltage regulator, they do actually try to preempt VDROOP. So they'll send a vid request that is higher, so when the CPU thinks that it's about to be hit with a big load transient from like low load to high load, it will actually request more voltage ahead of time, so that when the transient hits, the voltage ultimately doesn't end up too low. Now, the problem with this is that the CPU does it like all of the damn time, even when it's like not appropriate to do that at all, and that leads to some crazy high voltages. So, Like right now we've already seen like 1.54 volts, but earlier when I was like pre-testing, I managed to get a voltage reading as high as 1.6. Which I don't know if we're going to get that right now. Oh, there we go, 1.55. This is single core Cinebench. This tends to make the CPU kind of upset. Because, yeah, in single-core Cinebench, the average voltage gets very high, and then if you move the mouse around, that freaks the CPU out, so it starts sending silly vid requests. Yeah, there we go, 1.56. 1.57. Funnily enough, like, opening random programs and stuff tends to trigger this. Like, the 1.6 I caught was actually opening... No, I think it was starting Cinebench 20. But yeah, that's so it's kind of random as to when that happens. There is a little bit of also like the voltage regulator not reacting to the video request quite perfectly. That's mixed into that, but like the video request itself is already insanely high. I don't know. We'll just like start opening things and see what I can do with that. No. Let's get hardware info open. Actually, I'll just show, like, well, I mean, we do want to kind of take a look at the boost behavior. So actually, in this single core load scenario, right, and mind you, this Intel default settings is actually better than the old profile, like the old, like, Gigabyte default settings, because Gigabyte default settings on this motherboard would actually right now be requesting, like, 1.5. So it would be even worse. But yeah, this is not exactly great. And you can see we're getting our 6 gigahertz boost on cores 6 and 7. And we've now hit 1.578 on one of those spikes. And actually, you know what? Let's try capture some of these and like look at them closer. Because at a glance, like to me, they initially just look like transients, where like the CPU goes from like a high load to low load scenario. But some of these are way too boxy for that, like this one. Like that's just really boxy. Whereas like a actual like transient spike tends to be very sharp. These were easier to capture on the 13600. Yeah, on the 13600K. But yeah, so we regularly have these like blips that go into quite high voltage. I mean, I guess I could show like an actual like regular transient spike there. We have another one that's pretty high. So we'll just go back to run. And if I move the mouse around, you can see that, yeah, like the whole thing kind of freaks out. Which is normal. Like, moving the mouse around just is one of my favorite ways to cause a bunch of, like, random transients, because Windows basically freaks out anytime there's any user input, because it's like, oh, I need to get ready for what the user is about to do. And so it interrupts whatever workload is currently running. So anyway, for comparison here, we'll just load up to, like, 100%. And you can kind of... I'm going to try trigger on some of these spikes we're getting now. Like, these are a lot sharper, right? Like, these are a lot more just a spike, not like a block that we were getting before. And oh, here we can see some power management in action doing its thing. And there is a bit of, like, when we get those really tall spikes, there is a little bit of, like, the voltage regulator. Like, here, it seemingly was aiming for a little over 1.3 volts, but you can see that it, like, overshot the initial ramp up a little bit. So there is a bit of that mixed into it as well. Yeah, actually here you can see that really clearly, how there's like a little bit of overshoot on the ramp up, but so that gets mixed into the like really tall spikes as well, but we're at 10 milliseconds. I'm going to put the trigger out. And so, yeah, so right now we're like getting a bunch of voltages that are above 1.5 volts. I unfortunately didn't manage to randomly trigger that 1.6 incident, which is, yeah. I mean, I really wish I did. Oh, there we go, 1.59. Right at the end of the benchmark. So yeah, and this isn't the motherboard's fault. The fault. The motherboard is literally just doing whatever the CPU tells it to do right now, right? Because if we look at our vid requests and hardware info, and one thing to keep in mind is hardware info doesn't poll the CPU as quickly as the oscilloscope measures the voltage, right? Like some of those, like these spikes are down in the like like tens of microseconds range or like hundreds of microseconds. Hardware info, even at max refresh rate, is like a millisecond polling rate. So we simply cannot catch these kinds of spikes in software. Okay? Like you just can't. Unfortunately. Yeah, and also like changing the polling behavior of hardware info actually makes it. Oh, I didn't have it set to 1,000, so whatever. But like if you change the behavior, it also like changes how much load is on the CPU because checking all of the sensors 1,000 times a second instead of every second. Yeah, that takes some effort. So anyway, let's get the CPU to stop doing that. With literally one setting in the BIOS. Now, there is one downside to, like I mentioned earlier, there is a downside. This slows down the CPU even more than the Intel default settings. But if you don't want to go through a whole bunch of tuning and you have a Gigabyte motherboard and you're concerned about like degradation, you just go here. Oh, and I just breezed through that, so... Let's make this more obvious as to what I just did. I'm going to load optimize defaults. So, first of all, if you're in this menu, press F2. And then once you're in the tweaker tab, go all the way down to the advanced voltage settings. Also, if you're wondering how I jump from like one end of a menu to the other end this quickly, the home and end buttons on your keyboard will skip to the bottom or the top of whatever menu you're in. So, yeah, that's how I do that. Anyway, so yeah, we go to, so in Tweaker tab, you go Advanced Voltage Settings, then CPU VRM Settings, Internal VR Control, then you enable that, and then you scroll down to IA VR Voltage Limit. Now, this sounds like this sets a voltage limit on the voltage regulator. It doesn't. What this does is it tells the CPU that there's a voltage limit. And so now, whenever the CPU wants to request a voltage higher than 1.4 volts, it just won't. Which also means that on my CPU, this disables 6 gigahertz boost. Because my CPU's 6 gigahertz boost has a vid of 1.498. But I mean, you can set this to arbitrary numbers, at least between, 0 and 799. Because that's a useful limit, isn't it? But like, yeah, like if you were super paranoid, I guess you could set it to like 1300. I wouldn't do that because your CPU is going to end up very, very slow. But if you just want to shave off the spikes going over 1.5 volts, you can set it to 1.5. And then it'll basically max out at like 1.49-ish. But if you set it to like 1.4, which is what I would probably do, just because, like, the thing is, as far as I'm aware, most of the failures are on i9s, and there's also like a decent number of i7s. And the thing with the i7s and the i9s that they sort of share in common is that most i9s will have a vid voltage of more than 1.4 volts. Actually, I'm not aware of any i9 that has less than 1.4 volts for their max vid. And then with the i7s, the max vid is like the worst one I've ever seen is like 1.43, right? So you can get quite a lot of i7s that are pretty close to 1.4 or higher. So I'm thinking like, okay, you maybe want to knock it down to like 1.4, but maybe 1.45, like I'd say 1.4. Yeah, that like it might be overly careful. But it, like, depends how much you value your CPU, in my opinion. Like, how, yeah, like, you know. Hopefully Intel comes up with a better patch than this, or they come up with a workaround to the performance drop that this causes. Because, yeah, this literally just acts as a hard, like, vid limit. So I'm going to reset the stats on the oscilloscope. So now we're going to see what kind of max voltages we get with the limiters, like with the voltage limit set to 1400 millivolts. And from pre-testing, we basically shouldn't see anything higher than 1.39-ish. So we've already hit the max voltage, and it's just not going to go over that, which is pretty cool. And the way this works is it literally just, like, the CPU now, anytime the CPU like is like, hey, I want, X voltage for Y frequency. If X is bigger than 4, it just doesn't do that, and it lowers the frequency, which is why there's a performance penalty. So, yeah, now if we run, Cinebench 15, 20, 23, Prime 95, it doesn't matter what it is. Like, it's not going to go over 1.4. It is going to be slower, though. So, yeah. I mean, Cinebench 15 doesn't see much of a performance drop, but in Cinebench 20, it's like 23, it's like 1,000 points. The Intel default profile with this CPU spits out about 37,000, and with this turned on, it should be like 36,000, or I might be misremembering. Might be 36. This might be 37,000, and the Intel defaults are like 38,000. But yeah, so now you can see, like, we're just not going over 1.4 volts. I guess also I could show what happens if we set it to 1.5, which also the fact that we get this, like, really just, like, we get this, like, brick walling effect on the max voltage, to me is another indication that those big voltage spikes we were seeing, yeah, they're not transients. Those are actual vid requests that the CPU is sending for some bizarre reason. Because, like, I'm actually, you know what, I am actually just going to bump this up to 1.5. Like, at this point, you understand what this does, right? Like, if, like, whatever voltage you want the CPU to stay under, you just punch that into the VR limit, and no more. You will no longer go above that voltage. However, any frequency that has a vid higher than whatever limit you set is gone now. Like, you just, like, in this configuration, my CPU will never hit 6 gigahertz. Because the 6 gigahertz vid is at 1.498 for this CPU. So that's the downside, right? Like, the lower you set this, the less, like, the more boost you lose. Okay, no, not 1.55. Let's set it to 1500. And I don't need to reset the stats now because the max is gonna, like, the recorded max is lower than the, max we got at 1400. So, yeah. So at this point, like, you get what it does. And yeah, I'm honestly kind of surprised that Intel didn't use this right out of the box. Because, like, it's a pretty neat feature if you ask me. Like, honestly, I've been, like, digging through some of the, like options there are in the Intel BIOS, like, in the, yeah, on, like, some of the options in the BIOS. And I am, like, Intel has these, like, various functions in the BIOS to do stuff, and as far as I can tell, none of the motherboard vendors have bothered to actually use them correctly. Because they've definitely used the AC load line incorrectly. But yeah. Anyway, so I'll have another video that sort of shows a way of limiting the voltages without necessarily tanking the performance as hard. Actually, I guess we could combine it with the the VR limit here as well. But yeah, if you just want a really simple, like, hey, I don't want the voltage to go above X, you just punch this in and you're good. Apparently too hard to do that at the factory, though. Real difficult to, you know, set one thing in the BIOS. Like, obviously it makes the CPU slower, and, like, Intel really wanted to win those benchmarks. Ultimately just to get beaten by the 7800X 3D anyway, so that worked out great, didn't it? But yeah, now it's just not going to go over 1.5 volts. And it doesn't matter what I run, it doesn't matter how I run it, it just, like, we'll probably maybe see, like, a 1.49, but 1.5, like 1.55, 1.56, 1.59, like we saw with the just clear CMOS default settings, yeah, that's not going to happen anymore. Now, the downside is, like, you can see that here when we're running, like, you know, single-threaded Cinebench, we're now limited to 5.9 gigahertz, and the 6 gigahertz boost is, like, barely ever active. It did still manage to show up, probably while I was, like, opening files or something. Yeah. Like, yeah. So that's how this works. And then I guess as a, you know, final comparison, I can, like, I'm going to turn the system off, clear the CMOS, and just go straight into the OS, and we're going to see what kind of voltages we get. I don't think we're even going to, like, we'll probably see more than 1.55 volts before we even get into Windows. So, clear CMOS. Board fires up. One 1.49. Oh, right, we get the double post. That's just because the, like, board on that first boot, it didn't figure out, like, how to boot the OS, so... Because I think the OS that I have is, like, Legacy or something, and yeah. I'm pretty sure it's Legacy. Because, like, I like to play with DDR3 motherboards a lot of the time, and I don't like having to have, like, a bunch of different operating systems for everything. Or, well, like, I have certain drives that are, like, a dedicated OS, but then I have, like, other general purpose OSs, which just go everywhere whenever I feel like it. And this is one of those. It managed to not go above 1.55 before getting to the desktop this time. Well, yeah, before getting to the desktop this time. That's kind of surprising to me. Okay, 1.52. Let's open some random application. Okay, 1.523, benchmate, hardware info. I mean, Cinebench 15 for what, like, the end of Cinebench 15 for whatever reason seemed to be, like, the best at causing the max voltage to go up. Which is really random in my opinion. But even, like, single-threaded R20 was pretty bad. So let's start with single-threaded R20. Sometimes just starting Cinebench causes a really big spike. Like when it pops up. Didn't get it this time. Oh well, I'm sure if we run it and then I just move the mouse around, we're gonna get some fun voltages. Oh, there we go. Yeah. So this pretty consistently gets us to like 1.56 is running one thread of Cinebench and then moving the mouse around like 1.57. So yeah, these are vid requests because like if this was just like transient response issues, that setting in the BIOS shouldn't do this. Like shouldn't it be able to just remove those spikes like that. Um, so yeah. Anyway, let's do the R15. And yeah, we get 1.59. Though this might actually be a load release transient at the end. Though, at the same time, it didn't happen when we had the limit in place, so... Yeah. Like, honestly, I'm surprised that they didn't, like... Like, I don't know, is this function... Like, as far as I know, this functionality is, like, standard to Intel CPUs. So, like, I don't know why they can't just, like, roll out a patch where it's just, like, they enforce these voltage limits. Other than the fact that, like, yeah, it eats into the performance, but, like... As a... Like, at least on the lower end CPUs, right? Like, you don't have, like, if you have an i7 or something, there is no reason that even a potato grade i7 should ever be requesting more than 1.5 volts, right? Like, the i9s, I think, are just, like, screwed because they ship them at 1.5 volts. So if more, like, if 1.5-ish volts is unsafe for those, for i9, like, for those CPUs, there's nothing that can really be done about that. But, like, i3s and i5s, were ship like those all ship at like 1.3 like actually like really good i5s are like 1.2 volts, but like i5s are like 1.2 up to like just under 1.4, and then i7s are generally are like 1.3 to 1.4 volts, and then your i9s are like 1.4 to 1.55, with most of them being between 1.45 and 1.5. That's the regular K chips. The KSs go all the way up to 1.55. So, like, yeah, with the i9s, I can see why it wouldn't really be a great idea to just hard lock the vid below 1.5. But for like i7s, they could just lock them below 1.45, and the i5s could be locked below 1.4 or whatever, and it would just not have any downsides that I can like that I'm aware of. Maybe I don't understand how this, like I don't work at Intel ultimately. So maybe I'm not understanding what like if like other downsides there are to this functionality. But like to me, this seems like a really like if the priority is to get rid of the degradation, just tell the CPU not to request voltages higher than whatever, right? Like, especially when you have a setting for that, just do it. So anyway, yeah. So there. Hopefully this is helpful. Um, Like the thing is, I don't want to say that like this is definitely going to prevent degradation because I don't know that. I literally cannot know that. Um, but you know, if you want to like err on the side of caution and you have a Gigabyte motherboard, you do have this option in the BIOS. You can just go and like set a voltage limit of whatever you want, and the CPU will stay under it. Like really well stay under it. Like you literally doesn't even like accidentally overshoot the voltage. Now I'm not sure how this would behave if you had like a very aggressive load line configuration, but with the default configuration of the Intel default settings, yeah, this works really well as far as I can tell. So at least as far as like limiting the voltage goes. Again, the performance penalties are a separate issue as far as I'm concerned. Because you can have a fast CPU, or you can have a fast dead CPU or a working slow CPU. Slower. It's not that much slower. But anyway, so yeah, that's it for the video. So hopefully you found this somewhat interesting and or helpful. And yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp if for some reason you want to, like, torture your ears. And yeah, so that's it for the video. Thanks for watching, and goodbye.